Hello, my name is Jacob Hallam. Welcome to my paper slides presentation. My function is x minus 2 over x cubed minus 3x squared minus 10x plus 24. First, we must factor this function, and to do this we use the factor theorem. As you can see, the math is on the left-hand side, and it is discovered that x minus 2 is a factor of our reciprocal function. Then we put it through synthetic division using 2 as a factor, or as a divisor, and we come out with a quadratic function that looks like x squared minus x minus 12, and we put that through our factor method, and we get x minus 4 and x plus 3 as factors. So we know that x minus 2 is in the numerator and the denominator, so that makes a whole at 2. And because there's a whole at 2, we cannot exclude x equals 2 in our reciprocal function. So there's a graph of my function with as you can see, the asymptotes are clearly labeled, x minus 3 and x equals 4, as well as there being a horizontal asymptote 0. And then there's also our y-intercept, which is negative 1 over 12, and our whole at 2. Also, our turning point at 0.5, negative 0.082. So now on to the horizontal asymptotes. We have a horizontal asymptote rather than oblique asymptote because the degree of the denominator is greater than the degree of the numerator. And going through our math here, it is discovered that our horizontal asymptote is at 0. Now onto the vertical asymptotes. To find the vertical asymptotes, it is simply using the same method as finding the zeros for a function, and we use the denominator here, so x plus 3 and x minus 4, meaning we have as zeros that x cannot equal negative 3 and x cannot equal 4. We have our x-intercept, which isn't anything, because we cannot solve for an x-intercept as we have no values of x in our numerator. Our y-intercept is using the b values of both the numerator and the denominator. So we multiply 3 and 4, which equals 12. And then we divide, or negative 12, sorry. Then we divide 1 over negative 12 to find our y-intercept. Our turning points, which we only have one of. Our turning point is negative, or 0.5 and negative 0.082. I found the x value of this turning point in between the two vertical asymptotes, and then I plugged 0.5 in. Well, I used the same method as finding the zeros as illustrated on the right hand side. Then I plugged that into my function and realized that the y value of our turning point was negative 0.082. Our end behaviors: as x approaches infinity, y approaches 0, and as x approaches negative infinity, y also approaches 0. This happens because we have a horizontal asymptote at 0, which both of the graphs lean or go towards in very large or very small x values. Our domain and range. Domain is a member of the real family such that x cannot equal negative 3, or x cannot equal 4, or x cannot equal 2. This occurs because we have vertical asymptotes at negative 3 and 4, and we also have a whole at 2, so x cannot equal any of those points. And our range is y is a member of the real family such that y cannot equal 0, and this is because we have a horizontal asymptote at y equals 0. Symmetry. This reciprocal function is actually odd because it can be rotated about the x-axis 180 degrees and still be a function. Intervals of increase: negative infinity to negative 3 and negative 3 to 0.5, because they are increasing from left to right on our graph. And intervals of decrease: 0.5 to 4 and 4 to infinity, because they are decreasing from left to right on our graph. And finally, our positive intervals and negative intervals. There are positive intervals at negative infinity to negative 3 and 4 to infinity, because these are in the positive x-axis, and negative intervals in negative 3 to 4 because those are in the y values are negative. Thank you for listening.